So today we will talk about the second chance algorithm for page replacement, and we will talk about how it works. We have a string here, a reference string, and we have, four frames here. So the second chance algorithm gives a second chance as illustrated from the name itself. So the first thing is going to be first, and the important thing here is going to use a reference bit, right? It is going to use a reference bit to indicate that which page to replace. It uses 0 and 1. If someone has a 0 bit, it is going to replace it. If someone has 1, we will kind of decrement it to 0 and we will move on to the next one. We will replace the next one and not itself, right? We will see it in action. Okay. Just want to load more because I'm also going to store bits. So it's better if I have a big space coming up. Okay. Here I am. The bits are going to be 0, okay? So we have 1 here, we have 1, 2 here, and we have 1, 2, 3 here, and 1, 2, 3, 4 here, okay? But the point here is we are going to have 0 bits, okay? 0 here, 0 here, 0, 0, 0, 0, 0, 0, 0, okay, and 0. Okay, now 2 is already in here, right? So when we find the page that's already loaded, we will change its bit to 1 here. Others will be 0, okay? If we find the page, because that's ahead, we will kind of change the increment of the actual, 1. Again, we have 1 here, so we will again 1, 2, 3, 4, and let me also change that. It will also become 1, it will also become 1, and it will remain 0 and 0. Okay. Now we have 5, and we want to replace the 5, right? So one thing I want to mention is it works in FIFO ways. It works from top to bottom in replacement. It's basically also, implemented using the FIFO, means it will go from up to down. So I want to replace 5, right? So I will go from here, but because it has a bit of 1, it says that you're going to decrement it to 0, and you're going to move to the next one, right? Means you're not going to replace it with the actual bit you have, right? So we will just keep the actual bit as it is, and then again we see that we have another one here, so we also decrement it, and then we will move on to the next bit, and for the next bit we will replace here 5 for 3, and we have 4 here. Okay, bits are going to be 0 for both of them. 0 and 0. Okay, and now we have 6 because all of them are basically 0, so we can just start from the we did this one in the latest most, right? And then we're going to do this one because I told you the top to bottom approach, and we use the one that's really close, or you can say the just down the recent one we used. We will now replace 1, 1, 5, 6. Right? We will replace with 4 because we started from top to bottom. We replaced here 3 with 5, and now we can replace 4 with 6, right? So that was the whole concept, and the bits are going to be, of course, remain 0. Okay, now we have 2 here, so we have now 2 is not there. We're going to start off with again, so we'll replace 2 here with 1 because we're going to again start from the first one, then 1, then 5, and then 6, right? Okay, so we replace 0, 0, 0, 0. Now 1 is already there, so we'll just increase its count, 0, 0, 0. Because 1 was already in the loaded memory, we'll increase the count of its bits, or the reference bit, we can say. Then again 2 is also there, so we also kind of increase the count. Wait a minute. 1, 1, 0, and 0. Right. So we will have, wait a minute, we will 2 here, 1, 5, and 6. Now 3 is not there, so we'll again check so for the recent one that we really changed, I think was for 1 was already there, for 2, right? We changed 1 with 2, so now we're going to start with the second one because we have already changed this portion. We replaced 1 with 2, otherwise everything was same. And now we're going to do with the second bit. So we will go to the second bit, and because you can see the second bit is 1, we will decrement it. We will decrement it to 0, but we will actually replace the 3 with the 5, the next one. Okay, we don't decrement it or replace it with the one that we decremented it. We just decrement it and move to the next one. We have 0 here, and then we have 0 here, and we have 1 here, and 0 here. Right? 2, 1, 5, 6, right? Now again we have 7 here, so the recent merge that we really changed was this one, 5. And then I'm going to do if it's 6, we will change it to 7, 5, 1, 2. Okay, so now we have 1, 0, 0, 0. Okay. Now we have 6, so again we will move up because we have already completed by kind of changing 6 with 7, so we will move up. And the 2 is, we know that the 2 is basically 1 bit, so we will change it to 0 and we'll move on to the next one, right? So it means we will replace 1 with 6 because I told you that we go from top to bottom. 5, 7, right? And now we have 3 again, so we choose to kind of replace 1 with 6, and now we can replace 5 with 3. So we'll just do it 2, 6, 3, 7. I know it's kind of messy here, but you can get the idea. Okay, I think I didn't calculate the page yet, so we will do it to last. 0, 0, right? Now 2 is already here, so we'll implement the count. 0, 0, 0. 1 is already not there, so we'll do it. Don't hurt it, just jump in. 2, 6, 3, 7. Right? What was the latest change that we made? So, yeah, the latest change we made was okay. So if I choose this one, there was 2, 0, and then I placed 1 with 6, okay, and then I had this one, and then I placed 5 with 3. No, sorry, yeah, 5 with 3, and now I'm going to replace 7, right? So I will replace 7, 2, 6, 3, 1, right? So we have a counter of 1, 0, 0, 0. The 2 is already there, so the counter will remain 1, 0, 0, 0. Again, I'm going to write that down, 2, 6, 3, 1. And 3 is already there, so we're also going to have 6, 0, 3, 1, 1, 0. And 6 is already there, so we're going to have 2, 1, 6, 1, 3, 1, 1, 0. So there were a lot of page heads that I didn't notice. Okay, so this is page head, this is a page head, this is a page head. Okay, 2, 6, 3, 7 page head. When it remains same, it's a page head. 2, 1, 5, 6 kind of page head. 1, 2, 3, 4. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3, 4, 5, 6, 7, 8, 9, 10. I think it's like 11 page heads. And the others are messes, which are like 19 because, 9, because it is basically the second chance algorithm. It's a kind of messy, but you can get the idea and still practice yourself.